Hey guys, welcome back to Explore Electronics. Let us see the complete solution for the model question paper of DDCO subject. So the question paper released by VTU. So this model paper effect from 2023-24 CBCS scheme. The code is BCS302. The first question demonstrate the non-associativity of NOR gate. Here you can see the OR gate and NOR gate symbol as well as the truth table. So for the OR gate, if you consider, the associative property or associativity satisfies. So here A plus B of plus C, A plus of B plus C can be written. And if you put any values over here for this diagram, it will satisfy this also. So that's why we say associativity satisfies for OR gate. But for the NOR gate, if you see, we need to take A plus B bar plus C whole bar. Similarly, A plus of B plus C bar whole bar. So these two are not equal. That's why we say for the NOR gate, associative property is not valid. That's why non-associativity of the NOR gate can be proved in this way. Take LHS A plus B whole bar plus C whole bar, and similarly RHS A plus of B plus C whole bar to the whole bar. Then we are simplifying this bar first. Then it leads to A plus B double bar. This plus becomes dot if you apply De Morgan's theorem. Then C bar. So here double bar get cancelled. It leads to A plus B into C bar. If you simplify the RHS in the same way, it gives A bar into B plus C. So these two are completely different expressions. So these are not same. So associativity is not valid for NOR gate. So NOR gate non-associativity can be explained in this way. Coming to the second question, here design a car safety alarm circuit. Here door, key, seat pressure and seat belt are given, and we need to consider the input as high. When the door is closed, key is in. Key is in means key is put into the car. That is what the meaning. Driver is on the seat. Then only driver is on the seat. Then only we consider it as driver is in, and seat belt is fastened. So in this case, we need to take inputs as 1. Alarm is the output here. Alarm A should be sound when two conditions are stated below. The first condition is that the door is not closed and key is in. Door is not closed means we need to take D is equal to 0. Key is in means K is equal to 1. So when D is equal to 0 and K is equal to 1, we need to take the output as 1. So if you see the block diagram here and the truth table I have written. So for this condition you can see D is equal to 0, K is equal to 1. You can see the first yellow mark here in the truth table. D is 0, K is 1. At that time no need to look for P and B values. We can directly take 1 as output as per the first condition. And if you look at the second condition, it says the door is closed, key is in the driver's seat. So when door is closed, key is in the driver's seat means it is not valid. How we can say key is in the driver's seat? Just key is inside the car, but it is not plugged into the key point. In the driver's seat means it is not valid. That's why I have taken this condition assuming that door is closed, D is equal to 1. Key is in means key is inside the car's key slot, and driver is in the seat, P is equal to 1. Otherwise, if as per the question, key is in the driver's seat means key is not plugged into the car key slot. Here the question says key is in means since it is a car safety alarm circuit, simply putting into the driver's seat it doesn't mean, right? That's why key is in the driver's seat doesn't makes it is a good logic. So we are taken key is equal to 1 and driver is in the seat, but seat belt is not fastened, means seat belt is not closed. So B is equal to 0. So for these conditions, this is the output 1110 is equal to 1. And if you take these values into the K map, it will leads to these values over here, and we will be getting these two groups, and these groups gives D bar K plus KP B bar. Now the next thing is we need to implement it using only NOR gates. and this is just for your reference using basic gate implementation, and you can look for using NOR gate implementation here. This gives the NOR gate circuit. It takes 6 NOR gates, and you can see here this is in between the value X. Here I have taken, and simplifying that we will be getting A correctly. So this is about the question car safety alarm circuit. With the example, explain the working of test bench in Verilog. So here we need to explain what is test bench and why it is required with a block diagram and explanation with an example. So first of all, test bench is a code that simulates a design without need of any physical hardware for testing, and it verifies the functionality and correctness of the digital design we write in Verilog. So test bench allows the designer, means the one who write the Verilog design, to catch the bugs and validate the functionality, and also optimize the design before the fabrication of the physical hardware. Before it going to the fabrication of IC hardware, if there is any bug in the code, it can be verified using test bench. So test bench block, you can see the outer block is test bench. It consists of our design under test. This is the Verilog design, and the stimulus we are going to write in test bench. Stimulus block will be there, and output checker will be there. This is what the standard block diagram for the test bench. And you can take half adder as example. Here I have given the design code and also the test bench. You can refer my videos in Verilog playlist, also in DDCO subject playlist. Clearly explains what is test bench, how the test bench is written, design code is written. And coming to the second question, demonstrate the positive and negative logic signal. So you can see positive logic means 0 to 1. Negative logic means here 0 will be considered as 1 and 1 will be considered as 0. So the negative logic and positive logic need to be explained here, and you can see here signal in the range 0, how the transition occurs and when it becomes 1. Those are the things you need to explain with respect to the positive and negative logic signal. And then we have one more question here. Digital system to be designed in which month of the year is given as input in a 4-bit form. Means from January to December we need to take the months as starting from 0000 and then February as 0001 up to 1011 for December, and which are all the months containing 31 days. Those months we need to consider as output 1, otherwise it will be 0, and rest of the inputs we need to take it as don't care. So for that you can see here from 0000, that is from January till December, I have taken the values, and accordingly I have taken 1 wherever the month is having 31 days, and the rest of the values after December will be taken as X. For this we need to write the SOP. SOP is this by taking the min terms into consideration. Similarly POS by taking the max terms into consideration. Here they have asked to simplify the SOP using K-map. So we have simplified this K-map SOP using K-map like this, and also implemented that using basic gates. So this is how the basic gate representation looked like. Cross verify this. If there is any error or mistake I have made while solving the problem, you please comment below. Then what is user defined primitives in Verilog? What are the general rules for UDP? UDP means the user can create additional primitives by defining them in a tabular form. So using the table format, you can see here the table, truth table is as it is put it in the primitive block of Verilog code. So this gives a user defined primitive that can be used in design. You can see here UDP is used. The name of the UDP here it is 02467. So 02467 is just the name of the primitive. You can give any name. So here 02467, why they have taken means whenever 0, whenever it is 2, 6, 4, 6, 7, the outputs are 1. That's why just they have given the name like that. So for this the truth table it can be written separately. Because of here the truth table is already included, I have not shown the truth table. Separately you can write the truth table first, and then write the code as it is, and then write the schematic for this. You can see the schematic over here for the UDP, and this is what the Verilog code, and also the rules I have given over here. You can read these rules while writing the UDP, what are all the things required. Coming to the next question, differentiate latch and flip-flops. The main difference between the latch and flip-flop is that latches are level trigger devices and flip-flop are edge trigger devices. And latches sometimes may contain clock or not contain clock also. Flip-flops are always clocked, means clocks are required. And the latches are constructed using logic gates, we can say, and flip-flops are constructed using logic gates, also using latches. And then coming to the 4-bit adder using 4 full adders. A 1-bit full adder is first required, and then we are going to use that while designing the 4-bit full adder. This is the ripple carrier adder diagram. It taking A0, B0, A1, B1, A2, B2, A3, B3 as inputs, and S0, S1, S2, S3 and C4 are the outputs. Implement Y of ABCD with the expression given using 16:1 mux and 8:1 mux also. So this is the truth table. I have taken all these minterms into consideration as per the expression function given. So 0, 1, 6, 7, 8, 9, 10, 11, 12, 13, 4 will be having 1, and in the other places I have taken 0. So accordingly here in the multiplexer, considering the inputs from I0 to I15, and I0 it means 0, 0, 0, 0, it will select I0. So select lines are ABCD and inputs are like this. And wherever 1 is there, we need to connect those to 1 and zeros will be connected together to 0. This is the simple implementation. Then coming to the implementation using 8:1 mux, we need to take ABC as select lines. So these 3 become select lines and D will be the input. So we need to take the one more table here for D is equal to 0 and D is equal to 1. And these are the positions for 0, 1, 2, 3, 4, 5, 6, 7 up to 15. And D is equal to 0 and D is equal to 1. There are output is D is equal to 0, output is 1, D is equal to 1, output is 1. So here these two are 1s, I have taken I0 is 1. Similarly, when I1 is going to be selected, when I1 will be selected when ABC is 0, 0, 1, since these 3 are select lines. That's why when D is equal to 0, it will be 0, D is equal to 1, output will be 0. Means when select line is 0, 0, 1, the output will be 0, means we need to tie that I1 to 0. Similarly, as we took all the different values, it gives 1, 0, 0, 1, 1, 1, D bar, D bar. So you connect all the 1s together, I0, similarly I3, I4, I5, and 0 will be these two, I1, I2, and D bar, D bars, I6 and I7. This is how 8:1 multiplexer we can use for implementation of any expression. So the other video is there, separate video is there on this. It will explain clearly how we can do step by step. You can refer to that. And also the next question, explain different modeling styles using modeling styles used in Verilog with an example. There are 3 modeling styles: structural style, data flow style, behavioral style, and also gate level style. We can say structural style and gate level style are similar in this level. Otherwise you can take structural style separately and gate level style separately. Here the gate level style code is also written. This can be referred as structural style. Used all the gate primitives here in design of logic gates. Similarly, if you write the same code using data flow style, here assign statement need to be used and the expression for those gates need to be written. Similarly, in the behavioral style, I used always statement. In the always statement block, in the sensitivity parameter, we need to use all the inputs and the outputs are defined here within always begin and end. So this is behavioral style. The next question is BCD to XS3 code converter. So BCD means it is a number between 0 to 9 and we need to convert that into XS3, means we need to add 3 for that, plus 3. So if we take 4 bits, we need 4 bits to represent 0 to 9. So after 9 we have other input combinations also. For those we take it as don't care. This will be useful while grouping the things. So you can see the K-map and grouping and expressions for those. And the final implementation or the circuit will be like this. You can cross verify this by your end. Try to solve these K-maps and check whether it is correct or not. Comment in the comment section. And then the next question is define decoder. describe the working principle of 3 to 8 decoder, draw the logic diagram of 3 to 8 decoder with enable input, realize the following boolean function using 3 to 8 decoder and multi-input OR gates. So you can see this is the truth table. Block diagram I have not written here. You need to write the block diagram by taking X, Y, Z as inputs with an enable input, and all the other outputs are D0 to D7. And you can see the expressions will be like this. For D1 it is X bar, Y bar and Z into enable. Similarly, if you write D2, D3, D4, D5, D6, D7, it will be like this. And then you need to write the circuit diagram also. By using NOT gate and AND gate, I have written the circuit here. This is for the 3 to 8 decoder. Then they have given two expressions here, two functions to implement using decoder. In the first one we have 137. So directly connect 137 as the output lines will be the input for one OR gate. Then this gives the output F1. Similarly, 2, 3, 5 is the thing given in the question. Connect 2, 3 and 5 outputs of the decoder to one OR gate. This gives the expression F2. That is the second half of the question. Fifth question. Write 1 address, 2 address, 3 address instructions to carry out C is equal to A plus B. So here we need to explain how the 3 address instruction can be used for the addition of A, B and put that result into C. How 2 address instruction can be used and how 1 address instruction can be used. Here is the explanation for that. You can go through this, and this is sufficient to get 5 marks. Explain the basic operation concepts of a computer with a diagram. This is the diagram relevant to this question. So there is a memory and processor, how it communicates with respect to the different registers in the processor. So memory is going to fetch from the different registers, and the execution of any instruction, we can take an example of addition instruction here, and we need to explain how the execution will be using fetching the instruction from main memory and then adding that, putting into the result. So fetch, decode, execute is the 3-step process. We need to explain with respect to the registers are concerned. Explain processor clock, basic performance equation, clock rate and performance measurement. So first thing is processor clock. Why clock is required? What is the need of clock in the processor and a computer? How the different execution will be scheduled with respect to the clock, and related explanation we need to write. And then basic performance equation, as we know, how the performance of the computer will be measured with respect to instruction execution and the number of steps it takes, and clock rate, like that. And the third thing is clock rate. Clock rate, how it is measured. And finally performance measurement using spec rating need to be explained here. Then sixth question, write an ALP, assembly level program, of adding a list of n numbers using indirect addressing mode. Here is the ALP given, and also using a loop to add n numbers, steps also given. You can go through this, and here you need to explain how actually the looping works also. What is addressing mode? Explain different addressing modes with an example for each. Different addressing modes are shown here, starting from immediate, register, absolute, indirect, index, base with index and offset, relative addressing mode, auto increment, auto decrement. And with that, you need to write the definition of the addressing mode here. And for each and every addressing modes, you need to give the example and briefly explain how that works. Explain the following: byte addressability, big endian assignment, little endian assignment. So byte addressability, and here the 3 things are there, it just for 2 to 3 marks. So you need to explain in brief how actually the byte addressability works. So it allows each byte in memory to have unique address. So successive address corresponds to successive byte locations in a memory, and you can give examples like if the word length is 32 bits, each word consists of 4 bytes and successive words are located as address 0, address 4, address 8, etc. Similarly, big endian and little endian assignment, you can explain this with a block diagram or some assignment values like this, how the bytes are going to be stored with MSB to LSB or higher address to lower address like this. Then draw a neat diagram of memory hierarchy in a computer system discuss the variation of size, speed and cost per bit in the hierarchy. This is the hierarchical diagram here. You can see starting from magnetic disk secondary memory to the registers and cache, the speed increases and also the cost per bit increases, and increasing size will be the reverse compared to that. That we need to explain with respect to memories. Then what is DMA bus arbitration? Explain the different bus arbitration techniques. Just explain what is DMA bus arbitration first. Bus arbitration is required because to schedule the different requests and different arbitration schemes we need to explain here. A daisy chain is there and distributed arbitration scheme is there. A brief explanation is given here. You can also explain more since this is for 10 marks. With neat sketches, explain various methods for handling multiple interrupt requests raised by multiple devices. When multiple devices giving a request to the processor, how actually the multiple requests are going to be, interrupt requests are going to be handled. Here you can see implementation of interrupt priority using individual interrupt request and acknowledgement lines are shown. This is daisy chain as well as arrangement of priority groups, and here is the different ways and brief explanation given. You can go through this. What is cache memory? Explain the different mapping functions used in the cache memory. There are three techniques: direct mapped cache, associative mapping and set associative mapping. You need to explain these three in brief. Before that, we need to write the definition for cache memory. Cache memory is a high speed memory which is near to the processor. It is volatile and to store the frequent access data and instructions, and it will reduce the time takes to the CPU to retrieve the information from the slower main memory. Main memory is slower and cache memory is faster. Why? Because cache is kept very near to the CPU. And these are the different diagrams indicating direct mapped cache, associative mapped and set associative mapped cache. Explain the single bus organization of computers and fundamental concepts with neat diagram. So this diagram indicates a single bus architecture. A straight bus here indicating a single bus which is allowing all the registers as well as ALU and control signals to flow through. So you need to explain this with a neat diagram as well as with the some brief explanation. This is the main hardware component of a processor and how the execution will be, how these things are comes into picture of execution of an instruction. You can explain. Write and explain the control sequence for execution of an instruction add of R3, R1. Fetching the instruction, fetching the first operand means the content of memory location in R3, performing addition and then load the result to R1. This is the instruction flow, how it will execute. And the control sequence also we need to explain here. The mainly control sequence need to be explained. So here at the right you can see 7 steps where the controlling functionality, how actually it will be. You need to write that and explain in brief. 10th question, explain with an example different types of hazards that occur during pipelining. So this is very important question, repeatedly asked also. So the different types of hazards in the pipeline stalls you need to explain here, and you can see different diagrams also you need to write with respect to pipeline stall. And this much of explanation you can go through and understand how actually the hazards are going to be occurred. And write and explain the control sequence for the execution of an unconditional branch instruction. So the control sequence we need to write for an unconditional branch instruction is executed. So this is the steps involved or the control sequence for an unconditional branch instruction, and this is the brief explanation for that. This is about the solution for model question paper. Please go through these things in detail, and you can refer textbook. The textbook link is also given in the description of this video for more explanation. If the question is asked for 10 marks, this much of explanation is not sufficient. You need to write in detail, or you need to write a complete page of explanation with a diagram or some points like this to get the full marks. Thank you.